Professor Kelthak stood in front of the holographic display, reviewing the admission records for the 500th time. The Vrelian's 4 crystalline calculation nodes glowed softly as they processed the information. In all their 340 years of teaching at the Galactic Engineering Academy, they had never seen anything quite like this. 3 humans had been accepted into this year's cohort. 3 out of 847. Applicants from 23 different species across the Galactic Union. Humanity had only joined the Union 12 standard cycles ago. Barely enough time to learn proper galactic etiquette, let alone master the complexities of universal engineering standards. Yet here they were, about to study at the most prestigious engineering institution in known space. The Academy floated in orbit around the neutral moon of Tethys Prime, a massive station where the brightest minds came to learn the codified standards of universal engineering. These standards filled 40,000 pages and had been refined over centuries. They guaranteed 0 critical failures across 600 civilizations. Every problem had one correct solution. Every tool had one proper use. Every material had specific applications that could never be altered. This was how the galaxy worked, and it had worked perfectly for over a millennium. Maria Chun arrived first, her magnetic boots clicking against the station's metal floor as she stepped through the airlock. She was young by human standards, maybe 25, with dark hair pulled back in a practical ponytail. Behind her came Jamal Okonkwo, tall and thoughtful, constantly looking around at the station's architecture with curious eyes. Dmitry Volkov came last, quiet and methodical, already reading through the course materials on his personal display device. The orientation hall was enormous. 412 students from across the galaxy sat in perfectly arranged rows. The Vrelians sat with their backs perfectly straight, their calculation nodes humming softly. The Takari students had already organized their materials with micrometer precision. The Quorum students sat motionless, their logical minds already processing the welcome information before it was even presented. The humans sat together near the back. They seemed small compared to most of the other species, unremarkable in almost every way. Professor Kelthax made a mental note to watch them carefully. Humans had a reputation for being unpredictable, and unpredictability had no place in proper engineering. The first week was brutal for the human students. Every lecture presented problems that had single specific solutions. The methodology was always the same. Identify the issue, consult the codified standards, apply the correct formula, use the designated tools, and verify the result matched the predicted outcome exactly. Deviation was not just discouraged. It was considered dangerous. In structural integrity class, students calculated load-bearing requirements for a standard residential platform. The Vrelian students completed the calculations in minutes, their crystalline nodes processing the 16 required formulas simultaneously. Maria finished after an hour, her answer correct, but her method marked as non-standard. She had simplified 3 of the formulas by combining them, saving time but violating protocol. Her grade reflected this failure. In material science, Jamal questioned why certain alloys could only be used in specific applications. But this alloy has properties that would work great for thermal shielding too, he said, pointing at the molecular structure on the display. The instructor, a methodical Takari named Zixthar, shook their head firmly. The alloy is rated for structural applications only. Using it for thermal shielding would violate Standard 7432, Section 14, Subsection C. Such violations have not been tested. Untested applications are unsafe. Dmitry struggled most with the tool protocols. Every instrument in the Academy's workshops had a single designated purpose. A plasma cutter was for cutting plasma-resistant alloys only. A molecular bonder was for bonding specific ceramics only. A thermocoupler was for thermal systems only. When Dmitri suggested that a plasma cutter could also work on standard metals if you adjusted the intensity, he was reprimanded. "Tools must be used as specified," his instructor said coldly. "This is not negotiable." The other students seemed to thrive in this environment. They memorized the standards with ease, followed every protocol perfectly, and never questioned the established methods. The humans, by contrast, constantly asked why when they should have been accepting how. The practical examination in week 6 would determine which students could continue in the program. Each student was assigned a malfunctioning gravity stabilizer and a kit containing exact replacement parts. The task was simple: diagnose the fault using the standard diagnostic procedure. Identify the failed component, replace it with the correct part from the kit, and verify function using the approved testing sequence. Time limit: 2 hours. The exam began. The Vrelian students completed their work in 45 minutes. The Takari students finished in 53 minutes, each one taking extra time to verify their measurements 3 times. The Quorum students worked in perfect silence, their logical minds flowing through the problem without hesitation. One by one, students completed the exam and left the testing hall. Maria was still working at the 90-minute mark. Professor Kelthax watched her through the observation window. She had correctly diagnosed the problem, a failed resonance coil in the secondary stabilization circuit, but instead of simply replacing it with the provided part, she was doing something strange. She had taken apart a thermal coupler from a completely different system and was examining its internal components. At the 2-hour mark, only Maria remained. Professor Kelthax entered the testing hall. "Time has expired, Cadet Chun." "I just need 5 more minutes," Maria said without looking up. She was using a structural support rod as a lever, bending something inside the gravity stabilizer's housing. "The examination is complete. Please step away from the equipment." Maria pressed a button. The gravity stabilizer hummed to life. The diagnostic display showed green across all systems. She looked up at Professor Kelthax with a tired smile. "It works." Professor Kelthax approached the workstation. The gravity stabilizer was indeed functioning. They ran a full diagnostic. All systems were operational. In fact, the efficiency reading was 3% higher than standard parameters. But something was wrong. They examined Maria's work more closely, and their crystalline nodes flickered with alarm. The failed resonance coil had been replaced, but not with the provided part. Maria had cannibalized the thermal coupler, extracting a component that was similar but not identical. She had bent one of the structural support brackets to create a makeshift tool. She had bypassed 2 circuits entirely, rerouting power through a tertiary system that was technically optional. The repair worked, but it violated at least 7 fundamental principles of the codified standards. "What have you done?" Professor Kelthax asked quietly. "I fixed it," Maria said. "The replacement coil in the kit was the wrong voltage rating. Did you notice that? It would have worked, but it would have been running at 87% capacity. So I looked around for something that could do the same job. The thermal coupler had a component with the right specifications. I had to modify the housing a little to make it fit, and I bypassed those 2 circuits because they were just redundant safety systems that weren't necessary for basic function. It actually runs better this way." Professor Kelthax stared at her. The kit contained exact replacement parts. The kit contained a part with the wrong specifications. That was the test, to see if you would follow the replacement procedure correctly, regardless of the component specifications. The stabilizer would have functioned adequately with the provided part. Maria's smile faded. "But not optimally. Working is insufficient, Cadet Chen. Correct method is everything. You have used components for unintended purposes. You have modified equipment without authorization. You have bypassed safety systems. These are not minor deviations. These are fundamental violations of engineering principles that keep the galaxy safe. Maria looked at the gravity stabilizer, still humming smoothly with its 3% efficiency improvement. But it works better than the standard repair. That is not the point, Professor Kelthax said. You are here to learn proper engineering, not to improvise with unauthorized methods. Your examination is marked as failed. You will retake it next term, and you will use the correct procedures. Maria gathered her tools in silence. As she left the testing hall, Professor Kelthax watched her go and felt a strange unease. The human had violated every protocol, yet the device worked better than it should have. This contradiction troubled them deeply. Engineering was not supposed to have contradictions. There was right and wrong, correct and incorrect, safe and dangerous. The codified standards existed for a reason, but as Professor Kelthax looked at the modified gravity stabilizer, they could not deny the evidence of their own sensors. It worked. It worked better than standard dot. This should not have been possible. The professor made a note in Maria's file and tried to forget the incident. The codified standards had kept the galaxy safe for 1,000 years. 3 young humans and their strange methods would not change that. The galaxy ran on order, precision, and proper methodology. There was no room for improvisation in real engineering. Professor Kelthax would remember this certainty later. When everything changed, 6 weeks into the term, Maria Chun sat in the cafeteria with Jamal and Dimitri, picking at her meal. The food synthesizer had produced something that was technically nutritious, but tasted like spiced cardboard. Around them, students from dozens of species ate their own specialized meals and discussed the finer points of thermodynamics and structural load calculations. I got another reprimand today, Jamal said quietly. I suggested we could save time on the pressure vessel calculations by using an iterative approximation method. Apparently, that's not in the standards. I got written up for asking if we could modify the lab equipment, Dimitri added. I just wanted to add a safety feature to the plasma torch. They acted like I'd suggested blowing up the station. Maria nodded. We're not going to pass at this rate. They don't want engineers here. They want people who can memorize a manual and follow instructions without thinking. Maybe that's what engineering is in the rest of the galaxy, Jamal said. Maybe we're the weird ones. Before Maria could respond, the station's alarm system activated. A low pulsing tone that made her teeth ache. Around them, students looked up in confusion. The Varelian's crystalline nodes flickered rapidly. The Takari students immediately began consulting their personal devices for emergency protocols. Professor Kelthax's voice came through the station-wide communication system. All students and faculty remain calm. We have experienced a micrometeorite impact. The situation is under control. Please proceed to your assigned emergency stations. The cafeteria emptied in an orderly fashion. Everyone moved according to the evacuation protocols they had memorized on their first day. Maria followed the crowd toward Emergency Station 7, but something felt wrong. The alarm tone was steady, which according to the protocols meant a minor emergency. But she could see Professor Kelthax through a window in a command center 2 levels up, and the Varelian's crystalline nodes were flickering erratically. That was not the behavior of someone managing a minor emergency. The evacuation drills went smoothly. Everyone reached their assigned stations. Emergency supply containers were opened and inventoried. The station's automated systems confirmed all personnel were accounted for. Then they waited for the all-clear signal. It did not come. 2 hours passed. Students began to whisper among themselves. The quorum students, with their logical minds, started calculating probability scenarios. None of them were optimistic. Finally, Professor Kelthax's voice returned to the communication system, but this time it lacked its usual steady confidence. Students and faculty, I must inform you that the micrometeorite impact has caused more damage than initially assessed. The primary life support system has failed. The backup system is damaged beyond immediate repair. We have initiated evacuation protocols. Rescue vessels from the nearest station are en route, but they will not arrive for 4 standard days. A pause. When Professor Kelthax spoke again, their voice was carefully controlled. The station currently has enough oxygen for approximately 2 days. We are implementing conservation measures. Please remain at your emergency stations and await further instructions. The silence that followed was absolute. Maria looked around at the other students in her section. A Takari was calculating exact oxygen consumption rates on their device. 2 Vrelians had their nodes pressed together, sharing processing power as they worked through the problem. A quorum sat perfectly still, having already reached a logical conclusion they chose not to share. "We're gonna die here," someone whispered. Maria stood up. "Where's the main engineering lab?" "You heard the professor," another student said. "We stay at our emergency stations." The professor said to await instructions. "They didn't say we couldn't think." Maria looked at Jamal and Dimitri. "You coming?" They followed her through the corridors. The station felt different now, quieter, as if the walls themselves knew something was wrong. They found the main engineering lab converted into a crisis command center. Professor Kelthax was there with a dozen other faculty members, all clustered around a holographic display showing the station's damaged systems. "Cadets, you should not be here," Professor Kelthax said. But their voice lacked conviction. "What's the actual situation?" Maria asked. One of the other professors, a Takari named Zixtar, gestured at the display. "The damage is catastrophic. The oxygen recycler's primary catalyst chamber is destroyed. Completely unsalvageable. The backup unit's plasma condenser has a fracture through its core structure. Also unsalvageable. The emergency chemical oxygen generators have been depleted. They were only designed for short-term use during primary system maintenance." Dimitri stepped closer to the display. "What about replacement parts?" "The components required are highly specialized," Professor Kelthax said. "Proprietary designs, custom manufactured. The nearest supply depot is 3 star systems away. Even if we could get them here, the rescue ships will arrive before the parts would. So we have working life support systems that are broken. And we can't fix them because we don't have the right parts," Jamal said slowly. "What about the wrong parts?" Every faculty member turned to look at him. "I do not understand," Professor Kelthax said. "Do we have any systems on this station that do similar things?" "Not exactly the same, but similar processes." "Anything that processes gases, or uses catalytic reactions, or handles pressure differentials." Zixtar made a disapproving sound. "There are various systems throughout the station that use analogous processes. Yes. The medical bay has tissue regeneration units that use catalytic reactions. The botanical research lab has atmospheric regulation for plant growth. The physics department has cooling systems for their particle accelerator. But these systems are not compatible with life support infrastructure. They use different power requirements, different material specifications, different parts that aren't designed to work together," Maria interrupted. "But they might anyway." Professor Kelthax's crystalline nodes flickered. "You are suggesting we violate the codified standards." "I'm suggesting we stay alive," Maria said. "You've already concluded that standard solutions won't work. You said the situation is unsalvageable. But that just means it can't be fixed the proper way. Maybe it can be fixed the wrong way." "There is no such thing as the wrong way that works," Professor Kelthax said, but their voice was uncertain. "Engineering principles exist for a reason. Combining incompatible systems would be dangerous. The power requirements differ. The materials are not rated for oxygen processing. The control systems cannot interface. Even if we could physically connect these components, we have no way to predict if they would function. We know for certain that doing nothing will kill everyone on this station, Dmitri said quietly. Trying something gives us at least a chance. The faculty members looked at each other. They were the greatest engineering minds in the galaxy, trained in the most rigorous standards ever developed. They had built civilizations, designed systems that never failed, created technology that worked perfectly across hundreds of worlds. And now they stood helpless, killed by a handful of rocks moving fast enough to punch through metal. You have 36 hours, Professor Kelthak said finally, before oxygen levels reach critical minimums. If you believe you can create a functional life support system from incompatible components, you may attempt it. But understand that when you fail, and you will fail, we will have wasted time and resources that could have been used for evacuation preparations. Maria was already moving toward the door. We'll need access to every lab and storage area on the station. And we'll need help carrying equipment. You will have it, Professor Kelthak said. I will assign student teams to assist you. But Cadet Chan, I want you to understand something. The codified standards are not arbitrary rules designed to frustrate you. They exist because thousands of engineers over centuries have learned from failures and deaths. When we say systems are incompatible, we mean that connecting them could result in explosions, toxic gas leaks, catastrophic pressure failures. You are not just risking your own lives. You are risking all 1,200 people on this station. Maria met the professor's eyes. Then we better not screw it up. She left the command center with Jamal and Dmitri behind her. They had a little over a day to build a life support system from parts that were never meant to work together. Parts that the galaxy's greatest engineers said could not possibly function as needed. The humans did not care what was possible. They cared about what was necessary. And right now, they needed to start taking things apart. The medical-based tissue regeneration unit was larger than Maria expected. It stood nearly 3 meters tall, a cylinder of gleaming metal covered in diagnostic displays and control interfaces. According to the technical specifications, it used a catalytic chamber to break down and recombine organic molecules at a cellular level. The process was similar, in principle, to how an oxygen recycler worked. Similar in principle was not the same as identical in function, but it was all they had. We need the catalytic core, Maria said. Jamal, can you shut down the medical systems without triggering a safety lockdown? Jamal was already at a control panel, his fingers moving through holographic menus. The safety protocols are hardwired. If I shut it down improperly, the whole medbay goes into quarantine mode and we won't be able to get anything out. So shut it down properly. That takes 6 hours and requires authorization from the chief medical officer. We don't have 6 hours. Can you make it think it's shutting down properly? Jamal grinned. Now you're thinking like a human. His fingers moved faster. Code scrolled across the display, commands that weren't in any manual. He was writing patches in real time, convincing the system that emergency maintenance protocols had been authorized. 5 minutes later, the tissue regeneration unit powered down smoothly. No alarms, no lockouts. Dmitri was already removing the access panels. Inside, the catalytic core glowed with residual heat. It was smaller than the oxygen recycler's catalyst chamber, only about 30 centimeters across. But the underlying chemical process was similar enough. Maybe, hopefully, they carried it to the main engineering lab, where Professor Kelthax and a dozen other faculty members watched with expressions ranging from fascination to horror. A Vrelian student had calculated that they had 33 hours of oxygen remaining. Another team had mapped out every system on the station that might contain useful components. The botanical lab next, Maria said, studying the station map. They have atmospheric processors for the plant growth chambers. We need those to handle the gas mixture. The Botanical Research Lab was a vast space filled with plants from 100 worlds. The atmospheric regulation system was built into the walls, a network of processors and filters that maintain perfect growing conditions for each species. Dmitri identified the main control unit while Maria and Jamal started disconnecting pressure regulators and gas mixers. These are rated for nitrogen and carbon dioxide processing. A Takari faculty member observed, "Not pure oxygen. The material composition cannot handle the oxidation potential. At oxygen concentrations above 40%, these components will begin to corrode." How long before the corrosion becomes critical? Maria asked. The Takari calculated silently. Approximately 72 hours of continuous operation. We only need 4 days. The rescue ships will be here by then. You only need 4 days if nothing goes wrong, the Takari said. If a corroded component fails, you could have explosive decompression of the oxygen supply. And if we don't try this, we have 0 oxygen in 32 hours, Maria replied. I'll take the explosion risk. They carried the atmospheric processors back to the engineering lab. The space was beginning to look like a scrapyard. Components from 6 different systems lay scattered across workbenches. Nothing matched. Nothing was designed to connect to anything else. The power requirements were all different. The control interfaces used incompatible protocols. This is insane, a quorum student said quietly. This cannot possibly work. Probably not, Maria agreed. But we're gonna try anyway. The physics lab yielded cooling components from the particle accelerator. The chemistry lab provided pressure vessels and flow regulators. The machine shop had piping and connectors, though none of them were rated for oxygen systems. Maria sent Jamal to the kitchen to get thermal adhesive, the kind used to seal food storage containers. Dmitri went to the recreational facilities and came back with carbon fiber from athletic equipment. You are going to seal a life support system with kitchen supplies and sports equipment? Professor Kalthax asked. The thermal adhesive has a higher heat tolerance than anything else we can find, Dmitri said. And carbon fiber has incredible tensile strength. It's not rated for oxygen systems, but neither is anything else we're using. They worked through the night. Maria's hands were cramped from holding tools. Jamal's eyes were red from staring at control interfaces. Dmitri had burned his hand twice on hot components and kept working anyway. Around them, faculty members and students watched, offering observations but rarely helping. This was not how engineering was done. This violated every principle they had spent their lives learning. But slowly, impossibly, a system began to take shape. The medical unit's catalytic core was mounted inside a pressure vessel from the chemistry lab. The botanical lab's atmospheric processors surrounded it, connected by piping that was technically rated for water systems, but would have to handle oxygen. The physics lab's cooling components were bolted to the exterior, maintaining temperature stability. The control system was a nightmare of jury-rigged interfaces, with 3 different operating protocols running simultaneously, coordinated by code that Jamal was writing and rewriting every hour as new problems appeared. The power consumption is 3 times higher than optimal, a Vrelian professor noted. The station's reactors can provide the energy, but barely. There is no margin for error. The thermal differential between the catalytic core and cooling system is outside safe parameters, another professor said. You will have expansion and contraction cycles that could fracture your seals. This connection point. A Takari gestured at a junction where kitchen adhesive held 2 incompatible pipes together, is a fire hazard. If the oxygen concentration increases in this area, any spark could ignite it. Maria nodded to all of them. Yes, yes, and yes. We know. We'll monitor the power consumption. We'll watch for thermal stress. We'll post someone with a fire extinguisher. What we won't do is give up. 35 hours after the micrometeorite impact, with oxygen levels at 14% and dropping, they connected the final component. The hybrid life support system sat in the middle of the engineering lab like a monument to desperation. It was ugly. It was dangerous. It violated so many standards that Professor Kelthax had stopped counting. "We are ready to activate," Maria said. Her voice was steady, but her hands shook slightly. Everyone should probably step back. No one moved. If the system failed catastrophically, stepping back would not help. Maria pressed the activation sequence. The catalytic core began to glow. The atmospheric processors hummed to life. The cooling system kicked in with a sound like grinding metal. Oxygen sensors around the lab flickered, initializing. Then the system sputtered. Something inside the catalytic chamber made a sound like a wet cough. The pressure readings jumped erratically. An alarm began to beep, indicating thermal stress on the main seal. "The flow rate is insufficient," Professor Kelthax said quietly. "The catalytic reaction is not reaching the required temperature." Dmitri was already moving. He grabbed a control interface and started adjusting parameters, pushing the system beyond its rated limits. The grinding sound got louder. The thermal stress alarm became more insistent. "You are going to burn out the catalyst," a professor warned. "We're going to die if we don't," Dmitri replied. He pushed the temperature higher. The catalytic core glowed brighter, almost white-hot now. The reaction rate increased. The atmospheric processors began working faster, sucking in the station's stale air and pushing out oxygen. The sensors around the lab registered 14.1% oxygen, then 14.3%. The system was working. It made sounds that no life support system should make. It shook and rattled and hissed. The thermal stress alarm never stopped beeping. The fire hazard Maria had worried about became real when a small flame appeared near one junction, requiring a student to stand there permanently with an extinguisher. The power consumption was so high that they had to shut down non-essential systems throughout the station to keep the reactors from overloading. But oxygen levels continued to rise. 14.5%. 15%. 16%. "It is working," Professor Kelthax said, their voice filled with wonder. "It should not work, but it is working." Maria collapsed into a chair. Someone needs to monitor it constantly. If those seals start to fail, or if the thermal stress becomes too much, we'll have maybe 5 minutes warning before everything comes apart. "I will organize monitoring teams," Professor Kelthax said. "Cadets Chen, Okonkwo, and Volkov, you should rest. You have earned it." Maria wanted to argue that she needed to stay, that only she understood how all the pieces fit together, but exhaustion was making her vision blur. Jamal was already asleep in his chair. "Oh." Dmitri was staring at the hybrid system with the glazed expression of someone who could not quite believe what they had accomplished. The oxygen level reached 18%. The system stabilized, its various warnings and alarms becoming a steady background noise that the monitoring teams learned to interpret. It ran for 4 days without stopping, ugly and inefficient and dangerous and absolutely vital. When the rescue ships finally arrived, the captain took one look at the hybrid life support system and called it the most horrifying piece of engineering I have seen in 40 years of service. It had kept 1,200 people alive. 6 months later, Professor Kelthax stood before the Galactic Union Engineering Council. The investigation into the incident had been exhaustive. Every decision was reviewed. Every violation of the codified standards was documented. The list was 147 pages long. In conclusion, Professor Kelthax said, the human students violated every major principle of proper engineering. They used components for unintended purposes. They mixed incompatible systems. They exceeded rated specifications. They created hazards that would never have been acceptable under normal circumstances. And they saved 1,200 lives because of it. The council chamber was silent. Representatives from 600 civilizations considered this contradiction. The codified standards have kept us safe for over a millennium, Professor Kelthax continued. They prevent failures by ensuring every engineer follows proven methods. But in doing so, we have lost something. When faced with an unprecedented crisis, when the standard solutions are impossible, we stand helpless. The humans do not. They improvise. They adapt. They use tools incorrectly and combine systems that should not work together. And sometimes, impossibly, it works. Kelthax projected a holographic display showing humanity's history of improvisation. The Apollo 13 mission, where human engineers built an air filter from spare parts to save astronauts in a damaged spacecraft. Field repairs in hostile environments where proper tools were unavailable. Survival shelters built from materials never intended for construction. Again and again, humans faced impossible situations with inadequate resources and found solutions anyway. We have been teaching engineering as a discipline of perfect knowledge, Professor Kelthax said. Follow the standards, use the correct methods, and you will never fail. But we never taught our students what to do when the standards do not apply. When the correct methods are impossible. When failure means death and improvisation is the only option. 3 months later, the Galactic Engineering Academy announced a new mandatory course, Adaptive Problem Solving and Non-Standard Applications. It was taught by 3 human instructors who had barely passed their regular courses, but had accomplished what the galaxy's greatest engineering minds could not. Maria Chun stood before a class of 200 students representing dozens of species. On a workbench in front of her was a broken atmospheric regulator and a box of random parts, none of them designed for atmospheric regulation. Today you are going to learn to fix this using the wrong tools, she said. Not because it is better than using the right tools. It is not. But because someday you might not have the right tools, and on that day, you will need to know how to improvise. A Vrelian student raised their hand. But the codified standards clearly state, the codified standards assume you have time, resources, and proper materials, Maria interrupted. Sometimes you will not. Sometimes you will have 36 hours to build a life support system from medical equipment and kitchen supplies, or everyone dies. The standards are important. Follow them whenever possible. But when they are impossible, you need to know how to work without them. She gestured at the broken regulator. Begin. You have 2 hours. The only rule is that you cannot use any part the way it was originally intended. Show me something that should not work, but does anyway. The students stared at their workbenches in confusion and mild horror. Then, slowly, they began to experiment. They tried connections that made no sense. They pushed components beyond rated limits. They made mistakes and started over. It was messy and inefficient and violated countless standards. It was, Professor Kelthax observed from the back of the classroom, the most important engineering lesson the galaxy had learned in centuries. The final examination for the course was held 6 months later. Students were presented with a critical failure scenario and given only inappropriate tools to solve it. The pass rate was barely 30%. But those who passed had learned something that could not be found in the codified standards, that sometimes the wrong solution is the only right answer, and survival requires the courage to try it anyway. The codified standards of universal engineering were amended for the first time in 800 years. Section 1, previously titled Fundamental Principles, was revised to include new text. When standard solutions are impossible and survival requires innovation, engineers must be prepared to improvise using available resources. The following principles of adaptive engineering are considered acceptable when no alternative exists: use of components for unintended purposes, combination of incompatible systems, and operation outside rated specifications, provided constant monitoring and appropriate safety measures are maintained. These methods are not preferred, but they are recognized as necessary in extreme circumstances. Humanity's reputation in the Galactic Union changed. They were no longer the species that barely understood proper engineering. They were the species that taught the galaxy's greatest engineers that knowing when to break the rules is just as important as knowing the rules themselves. And in the Galactic Engineering Academy's Hall of Honor, next to portraits of legendary engineers and displays of perfect designs, there now hung a photograph of an ugly, rattling, dangerous hybrid life support system held together with kitchen adhesive and sports equipment. It was the most beautiful thing anyone had ever seen.